Here's a fun biomechanical reality that everybody should know about a 45-degree angled leg press or leg sled, and that is once the weight itself is moving at this 45-degree angle, you're only lifting 71% of the weight. And it actually comes, if you're going to use math, it comes from calculating the sine of 45 degrees and round it off. It's about 71%. So if I put 1,000 pounds on here, including the platform itself, the carriage itself, I'm only lifting 710 pounds. So why should you know that? Well, it's about biomechanical reality. And yes, you're loading more weight on there than what you're actually required to lift. And it's a simple thing. It's gravity's down. If you're not lifting straight up and something else is helping to support part of that load, like this carriage, then you're only shouldering part of it because you're going non-vertical. So yeah, 71% of the weight. Now here's the thing. If I do put 1,000 pounds on there to get my 710 pounds of resistance, two things you need to recognize. Number one, this is still a variable resistance because as I lower, as the knee bends, as the hip bends, and the moment arms to each joint change as you lower, this resistance is actually getting heavier as you go down and lighter as you go up. That's the same as a squat or anything else. 200-pound squat is getting heavier as you lower due to the change in moment arms. In other words, it's an increase in the torque of resistance at each joint progressively as you go down and regressing as you go up back to the top and are virtually balanced through each joint with a near zero moment arm. The other thing you have to remember is if I do have 1,000 pounds on here, that 1,000 pounds relates to the mass that's required to create 1,000 pounds, and that mass has inertial properties. It still has momentum, if you will, and kinetic energy and all these other properties that you would hear about in physics class, but what matters to you is if you're lowering this fast, if you're out of control, you're bouncing off the bottom, there's still the inertia associated with 1,000 pounds and its mass that you're having to start and stop. So control becomes of the utmost importance, even though your actual weight at any point in time is reflective of the 71% times the moment arm to each joint. So I mentioned that the load is roughly 71%, and that is the same weight regardless of where you are throughout the range, but the actual torque or the actual resistance you're going to feel is going to change and actually get heavier as you go down because as you fold up, the moment arm of that line of resistance is increasing in each joint. The same as if you lower yourself in a squat. The bottom of a squat is harder than the top of a squat due to the change in torque, which is reflective of the change in moment arm, not necessarily the change in the amount of force itself. But, this is an important but, most people don't get that they can alter resistance profiles. How many times have you heard people out there saying, oh, you got to move full range of motion, you got to move full range of motion? Well, A, full range of motion should be determined by the individual and the ability of their joints and muscles to perform that range, not by your externally viewed, chosen, arbitrary range you think is important for everybody. That's number one. Number two, just because you moved what you think is full range of motion doesn't mean there was even close to full range challenge. Because every single exercise, even one like this, that is, as far as the machine is concerned, same load at the top and same load at the bottom, it's a different torque of resistance on you at the top and the bottom. Even a linear resistance has a variable resistance. Most people don't seem to understand that. Every cable exercise is a variable resistance for at least two reasons, one of which is moment arm. Everything in the gym, a dumbbell is variable resistance for at least two reasons as you move it. So what you could consider is if I really want this person's full available range, their client defined available range that they can control and that they own, and if I want a full range challenge, then I have to modify the resistance for where they're weaker at one place and maybe heavy or stronger in another place. I need to modify my resistance profile to match their strength profile. Now I can do that by simply using a heavier weight at the top and move shorter and a lighter weight at the bottom to match the bigger moment arms. And I can make that work, but you also can do it by understanding just a little bit of physics or the properties of the devices you're using. For example, we mentioned the inertial effects of this thing earlier being influenced by your acceleration and deceleration rate, not by the weight, the angle. But something else you can do, and we do it all the time, and there's a lot to learn about it, so I just don't want you running around messing up with this thing and hurting somebody. And it's not just to make things easier, it's to make them appropriately challenging at each point in the range. We will often use tubing, loops such as this, and calculate exactly how much it provides as you increase it from this length to 200% of its length, or from this length to maybe 300% of its length, where it's going to be pulling at, close to 100 pounds. But you can offload at the bottom. So as I mentioned, as this thing goes down, we have some devices up here where you can choose the amount of tubing and make it so that as you go through your excursion, your specific range, how much do you want pulled off at the top? And you, of course, want the full load of the weight. How much you want pulled off at the bottom, and you want the full load of the weight at the top. You don't want it pulled off at the top. You need to be responsible for that. And how we would make that occur. And the cool thing about tubing, not only is it pound per pound pulling something off at each point in your range, it almost provides what I like to call an inertial dampening effect. I mean, it also slows the thing. So it does help you with the inertial component. Now, having said that, I think it's real important to realize that controlling inertia is an important part of a training adaptation. So I wouldn't always use this version of offloading where you don't get the inertial thing. It might be great for somebody with arthritis, great for someone with patellofemoral problems because of the increased forces they usually have when they decelerate at the bottom. It might be perfect for them, but for an awful lot of people also, I'm going to want them to deal with the load and its full inertia at the bottom. I'm going to change the profile by adding as they go up. So I'm more apt to use something like maybe this, and a stair-stepped webbing device, so I can change it based upon their excursion. And at the bottom, this will have some slack in it, just a little slack at the bottom of their excursion, so that they're dealing with this load and its inertia, and having to control it and decelerate it. It's like pulling into a parking spot right up against that parking block, super controlled out of there. Then they can use a little more speed throughout the thing. But those inertial forces are huge. And if you think it's all about explode, 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 you don't understand forces, and you sure don't understand knees and patellofemoral joint. But then as they go up, this is incrementally increasing and adding load at the top. So at the top where they're nearly balanced, and you realize when your leg is near straight, the forces going through it create zero torque. So you can add load via something like this to offset the decreasing moment arm at the knee and the hip as you head towards the top. And if you haven't felt something like that used specifically with strategically used tubing, not just getting tubing with a handle on each end and wrapping it around there, that doesn't work out very well. But the more you learn about this, and that's why we spend so much time on it in our mastery program, because it's such a useful device, especially for anybody with compromised joints and that's so many people that we end up dealing with. They appreciate what we offer more than anybody else because everybody else is just beating the crud out of their joints. We're actually helping them with their joints. Now, every one of these 45-degree leg presses is slightly different depending on the manufacturer, and each manufacturer has even had different versions in their lineage. So you might have a one brand that was very different 20 years ago than what they're putting out today. Every angle within this thing and its adjustability or lack of adjustability becomes an issue for the setup of each individual. You cannot use a choreographed, predetermined setup for everybody you put on this thing. There's so much to figure out, and of course you need to do that with a pretty darn lightweight, maybe the weight of the carriage itself. And that's something that varies so much from company to company. This one has, I think it ends up being, I can't remember, I wrote it down somewhere. It's about 70 pounds, the carriage itself, at this angle. It's providing about 70 pounds. And I've seen some of them that were 170 pounds because of how they're built, and you can put so many more plates and stuff like that. Anyway, so that's going to be different in every one of these. Also, here's something you might think of, and I like this order. It can be helpful. Adjust or assess foot placement height first. Where you put it on the foot plate vertically first. And the second you start making that decision, you've got to make a back pad adjustability decision. This adjustment right here. And if yours doesn't adjust backwards, then you're going to have some trouble because this is vital. I might put the feet up higher if I'm trying to influence knee or back range or knee or back forces. I might put it lower if someone has hamstrings that are in super protection mode and aren't allowing much length. But I also could choose a foot placement based upon knee and back forces, but then alter the back pad to make up for the hamstring thing. So this combination of factors must be explored, trial and error, pretty precisely as part of the setup. And as you add load, as they progress and they do more load, that might need to be altered ever so slightly, might need to be changed or adjusted ever so slightly. So you never stop assessing. You never stop looking for where this person needs to be to get the job done. And as their goals change, you might change placement, because this is not how you do a leg press. This is how you do a leg press for this person and their goals. Now, the next thing you're going to need to immediately consider after these two relationships, back pad, back and forth, vertical placement on the foot plate, The next thing I would consider is width, and along with width you have another immediate concern. As I adjust width, I can't just keep going wider and parallel. I have to start adjusting slightly outward, because the legs are pointing back towards the hip joints, which aren't adjusting in width. Obviously, they're stuck right here. So as my legs go wider, I've got an angle that needs to be commensurate with the change in width. So having done that, having played with that, then you can start to take a look at the actual performance. And here's a couple ideas. I'm going to call them default cues, meaning you can certainly change them, should change them when appropriate for a given individual. But this is part of creating proper alignment of the forces through the knee, medially and laterally. Once you get them set up, and it appears that their foldability is optimal for them, for today, for this goal, have them put a little more force on the outside of their feet, and I don't mean go clear up on the edge of their foot like this, but you can feel this, and you might barely see inside of their shoe, just a little shift where you see the medial side of their foot. Maybe it looks like it raises up against their shoe a little bit, and the outside of their foot is buried against the foot plate. That right there will change the medial and lateral forces, and especially if someone has a considerable or excessive valgus, and often the associated Q angle that you've heard me mention before. So there's some really neat tips on this thing. And to wind this up, in conclusion, a lot of people are probably sitting here watching this little multi-part segment on leg press and go, but why would you use leg press? Squats are way better anyway. Look, if you judge exercises that way, one is inherently better than another for some arbitrary reasons that you think are objective, then you really don't understand exercise. Because these decisions have to be made. The value of a given exercise is based upon who you're talking about. I hear people all the time say, squat's the best exercise. Yeah, not for my paraplegics that I work with. Not for my person that's an amputee. So there's a lot, you guys, not everybody's you. Your client's not you. Your client's not an athlete half the time. They're real people with real osteophytes and real arthritis and real muscles that aren't even eliciting contractions. So we have to adjust for them. This is part of being an exercise professional. It's not doing the same thing for everybody. And this device and similar leg presses can be great for someone whose structure is such that it influences their squat so dramatically the squat is not even a viable exercise for them. And I know you can't envision that, but it's true. Yes, they might be able to sit down in a chair with repercussions in their knee over 70 years of sitting. But to do it as an exercise and not understand how to manipulate that squat, or more importantly, build up to a squat by doing a leg press, and how to manipulate the forces on this, guys, this is what it's all about, is client-defined choice of exercise and client-defined manipulation of cues and the forces that come along with the cues.